We have seen how to apply the general power rule, which is a specific type of the chain rule, but let's now look at the overall chain rule. So let m of x be a composition of functions, e composed with I of x, where I is considered the interior function, as e is considered the exterior function. Then the derivative of the function will be the derivative of e of I of x untouched the interior times the derivative of the interior function. Now, of course, both of those derivatives have to exist. So in general, this is how we think of the chain rule. We identify the inside function and the outside function. We then differentiate the outside function, leaving the inside function alone. So this is important because this is normally the most common mistake that is made. And multiply all of this by the derivative of the inside function. Okay, so let's take a look and let's put it to the test, as this will be the best way that we can practice. And as you do it over and over again, you'll kind of get a hang of the whole inside-outside part. So the inside part here, the inside function, is going to be 2x cubed plus 3x. While the exterior function is going to be x to the 5/3. Okay, and when you input I into here, then that's the composition of the function. So you're going to have e prime, so y prime, it's going to be the derivative of the exterior function without touching the inside times the derivative of the interior function. So how do we apply that? What we do is we take the derivative of this first, so we bring down the 5/3. We don't touch the inside. We subtract one from the top because that's how the power rule works, which is going to give us 2/3 times the derivative of the inside function, make sure to use parentheses, 6x squared plus 3. And there it is. Okay, so let's look at another one. Okay, what is my inside function here? My inside function is the power that e is 2. So I have that the inside part is 5 minus 2x squared. And the exterior function is e to the x. So if I was to compose this, right, that I would go inside of x right there. Okay, so when I take my derivative, y prime, so remember on the side here that when you take the derivative of e to the x, it's just e to the x. Okay, so I'm going to have that y prime is equal to e of the inside function times the derivative of the inside, which is going to give me negative 4x. So more appropriately, we would write it negative 4x e to the 5 minus 2x squared. And here's my derivative. All right, let's take a look at another one. We have y is equal to the ln of x squared minus 7x plus I. Okay, so my interior function is going to be what's inside the ln, x squared minus 7x plus 1. My exterior function will be the ln of x, because this will go in here. So let's remember on the side that if we have the ln of x, the derivative of this is 1 over x. So I'm going to have that y prime is going to give me, okay, so I'm going to do the exterior function derivative, but with the interior function still there, right? Because I don't have an x, I have an x squared minus 7x plus 1. So I'm going to have 1 over x squared minus 7x plus 1 times the derivative of the inside, which is going to be 2x minus 7. So normally we put the numerator on top of this, and there it is. Okay, so I'm going to write, we're going to do one more and then I'll write a quick summary. Okay, so now we're going to be kind of using different rules together. So the first thing you need to notice here is, well, it's not only the chain rule that's involved, I have to actually use the quotient rule. And the quotient rule was t prime b minus tb prime over b squared. So the top is e to the 2x, and the bottom is x squared plus 4 squared. So why is the chain rule involved? Why am I putting this in the chain rule section? Well, because to take the derivative of t and of b, the chain rule is involved. So t prime is going to be e to the 2x times the derivative of 2x, which is going to give me 2e to the 2x. And b prime is going to be, I bring down the 2, I don't touch the inside, I subtract 1 from the top, and then I multiply by the derivative of the inside. So that's going to give me 4x, x squared plus 4. And now I can apply my quotient rule. So I'm going to have y prime is equal to 2e to the 2x times x squared plus 4 squared minus e to the 2x times 4x times x squared plus 4 all over x squared plus 4 squared squared. Okay, so at the top I'm going to be able to factor. I'm going to have some common factors. So let's look at what I have that's common. Well, first of all, I have a 2 and I have a 4. Right? So wait, let me underline everything, right? So I'm looking at these two things. I'm looking at this and I'm looking at this. And I'm looking at what I can factor out of both of those. So I have a 2 and I have a 4, so I can factor out a 2. Then I have an e2x and an e2x, so I can factor out an e2x. Then I have an x squared plus 4. I have 2 of them. And here I have 1 x squared plus 4. So I can take out 1 x squared plus 4. And then you look at what you're left with. So I took out the 2 is gone. I took out the e to the 2x, the e to the 2x is gone. And I took out 1 of the x squared plus 4. So I'm left with x squared plus 4. I still have my minus, of course. Okay, I do the same thing now, but for the blue. What do I have left in the blue version? I took out the e to the 2x. I took out 2 out of the 4. I didn't take out any x's. And I took out an x squared plus 4. All right, let's move this up a little bit. And of course, this is all over x squared plus 4, and this is to the 4th, because when you have your powers like this, you multiply them. So I have 2e to the 2x, x squared plus 4, times x squared minus 2x plus 4, all over x squared plus 4 to the 4th. These are all being multiplied together, which means that I can cancel this because everything is multiplied. I can cancel this one with one of these. And I'm left with 2e to the 2x, x squared minus 2x plus 4 over x squared plus 4 cubed. And here's my derivative. I actually think that sometimes what people think the most confusing here is the factoring. Okay, so just work on that. It will get easier over time. But again, when you're factoring, when you're doing the GCF, the greatest common factor, you're looking at what is common in the red part and the blue part, and that's what you're factoring out.